We're going to do a few slides. I'm not going to go through all 62 slides, but I'm going to go through a number of these slides on steganography, steg analysis, and crypt analysis. First of all, steganography, I've discussed a little bit what it is, a little bit. We're going to go into a little bit more detail. What it is, history of it, how it's used today, some tools that are used, besides one we're going to use Thursday. Steg analysis, what it is. And then we'll stop on the steg analysis meets crypt analysis, which is in password guessing and cracking steganography algorithms. Okay, so it comes from the Greek word, steganography comes from the Greek word steganosis, or steganosis, meaning covered. And the Greek word graphy mean writing, so covered writing. So covering something up, hiding something. Steganography is a process of hiding a secret message within an ordinary message, whether it be on a wall of a cave, as Jack mentioned, on a mathematical algorithm, up to technology and computer science with software. It's hiding a message within something else, and then extracting it at the end result for it at its destination. Anyone can view the message, will fail to know it's a hidden encrypted data. They see the bitmap image, it just looks like a bitmap image. Nothing special about it. Okay? And if you begin to think about this week, especially Thursday after the lab, there's a lot of data that can probably be out there using this type of technology that governments, businesses have no clue that they're out there. An example would be corporate espionage has been used a lot for folks to sell data to other companies very easily, like on a public website, by storing corporate documents in a photo and then posting it on a public or on their company website for like a picnic or some type of outing, or even parts or things that they sell, but hidden in those part pictures is actual corporate data that they're selling for tens and thousands and millions of dollars to competitions and competitors. And that does happen. Now, going on with as far as definition goes, in Greek history, warning of invasion, here's an example, warning of invasion by scrawling it on a wood underneath a wax tablet. Casual observers would see the tablet appear blank. Both Axis and Allied spies during World War II used such measures as invisible inks, using milk, fruit juice, or urine even, which would darken when it was heated. Invisible ink is also a form of steganography. And as a kid, I don't know if you guys ever played with this, but you could buy the invisible ink pens and then put it under a lamp and it would show up, or a certain type of light, maybe a certain type of black light possibly. Because there are actual paints you can buy to paint a wall, and then pens you can buy to write on the wall, and in normal light like this you don't see anything, but when you turn all the lights off and turn black lights on, you see hidden writing all over the wall. Mathematicians do this a lot when they're brainstorming or they're doing some type of research, so they won't be found out on what they're working on, some type of top secret mathematical equation or something like that. A lot of times you'll see that in universities. So invisible ink's pretty and it is a form of steganography. The U.S. government is concerned about the use of it, as you can imagine. Common use is including disguising of corporate espionage. It's also possible that terrorist cells may use them, and it's been proven that they have. It's rumored also that a common technique by Al-Qaeda was used by posting images to website, as I mentioned earlier. The terrorist cell could reveal the message with plans on a new attack from a common message, or maybe a state-driven newspaper, state-driven website. It's also a very good anti-forensics mechanism to mitigate the effectiveness of forensic investigation in such cases as child pornography, to where basically some folks into child pornography will use this technology to hide what they're doing, but you can use anti-forensic mechanisms to find out the software and find out the pictures that might be hidden on a hard drive. Modern digital steganography, data is encrypted. You insert and hide the data using a special algorithm. Some of these softwares allow you to choose the algorithm that you want, and it does not modify the contents of the file that you're hiding. The technique may be simply appending the data to the file and dispersing it throughout. Carefully crafted programs apply the encrypted data in such patterns that appear normal, like the one I mentioned on the board that we'll be using Thursday on the hide and picture program. Here's an example of a carrier file and a carrier file hidden with message. So the carrier file, we could say, would be an image. The message is hidden in the image, and then the carrier file is then sent on to the person that needs to get that message on the end. And then they extract it with that same program and read that message. Types of carrier files will be bitmap images, JPEG, GIF, WAV, MP3, and tons of other. Any format you could think of could be a carrier file, really. If a programmer wanted to create a program, it could be any format you want, the programmer wants it to be, could be used. Steganography tools, this is just a few of them. Steganosis, S-tools, Steg hide, invisible secrets, JP hide, camouflage, Hiderman, and then the one we'll be using Thursday, hide and picture version 2, and tons of others. If you just go Google search for steganography tools, you'll see thousands and thousands and thousands of tools out there. Popular sites, there's some links here, and you'll have this on the website as far as steganography tools and some cryptographic PowerPoints and also videos on cryptography. So, identifying hidden files. How do we do it? That's called steg analysis. That's the next part we're going to look at. So we looked at steganography, what it is, steg analysis, how you. So the definition of steg analysis is basically identifying that it exists, the existence of a message. Not extracting the message, just that, hey, we see something in here in this file format that represents steganography type of techniques. Steg analysis essentially deals with detection of hidden data. It does not reveal the data, it just detects it, is all it does. Now, how would you think it's meaningful to know that on your network drive you've detected data that could have steganography applied to it? How would that be helpful for a network administrator to know that?
If it's my company, I want to know what messages they're sending out. If it's data that belongs to me.
Exactly, and some of the softwares I'll show you, we actually show a couple tonight that are command prompt type of applications that you can run as a batch file once a day, point it to a certain folder on your network and just run it. It doesn't have to be the entire network. But yeah, as Jack mentioned, basically you want to know, as a network administrator, you want to know if people are tampering with your files, and definitely your bosses would want to know and the owners of the company would want to know. And granted, just like most of you, most people have never heard of steganography, much less used steganography, but it is possible to be used and easily available for anyone to download from any computer and use it in any location with really little or no trace of them doing that. Okay, if they know what they're doing, there's little or no trace of them doing anything. Ways. So one of the ways it's meaningful by identifying the existence of a hidden message, perhaps can identify tools. There are some steg analysis tools that will tell you the exact program used to do the steganography. If we identify the tool, perhaps we can use that tool to extract the original message. Or the way it could be used on a network admin side would be, I'm going to scan the network for this type of application that run from this point on my network. When it does run, I want to be alerted when somebody runs this application. I want to immediately be alerted where that IP address is located at, so where we can isolate it immediately. That would be another easy way to find it, instead of maybe trying to guess the password or whatever. Just run a tool to determine who's running it. Common hiding techniques would be appending to a file, hiding unused header portion of the file near the beginning of the file content. I've already talked about this one here on the third one, using the least significant bit to hide the file. Methods of detecting. The first one's definitely not a good one. Visual detection. Unless, again, they've hidden the file they're hiding is like really close to the size of the image they're putting it into, you're not going to see much degradation. In fact, on Thursday's lab, I have you guys hide notepad.exe into the bitmap file that we use, which is really close, if not over. I take it back. It's a little bit. You can't go over because it airs out. It's a little bit. It's pretty close to the size of the bitmap image. On Notepad.exe, you do see some degradation because I think it's about 97% the file size itself of the bitmap image. Audible detection, if you're using this software to hide stuff into MPEGs or WAV files or MP3 files. Statistical detection, maybe doing some type of histogram analysis of least significant bits on your files. Size difference, like structural detection, things like size difference on before and after. This could be easily done on a network because most networks back up their files on a nightly basis. So you could easily create a program or buy programs off the shelf to determine anomalies on file size from a 24-hour period within your network, and then get a report of all those files, and then determine who changed those files, why they changed them, to do more due diligence and investigation of it. Contents, have they been modified? And then checksum, have they been changed? Categories like anomaly, histogram analysis, changing of file properties, statistical attack, visual, audible, and then finally signature, a pattern consistent with the program used, like I talked about Photoshop earlier. Some of these hidden picture programs put a signature in the actual file itself. The one we used Thursday, I believe, does not. The hidden picture version 2 does not put a signature in the bitmap at all. But you might be able to detect it through least significant bit analysis, but not through. The goal of steg analysis is accuracy, consistency, and to minimize false positives, which you're going to get when you first start out scanning your network for anomalies. So detect by viewing it, we've already talked about that. I mean, unless you have the original picture, you're probably not going to be able to detect it. Hopefully you have pictures better than this on your network, but maybe not. But unless you have the original image to detect it against, you're not going to tell the difference. But again, if you do backups, which most companies do, who's going to go through each picture and look at them? Okay, this looks the same as yesterday. Okay, go through a million pictures like that. Nobody's going to do that. Okay, it's too time consuming. Kurtosis is basically the degree of flatness of a peakness of a curved describing a frequency of distribution. Basically on this one, you're looking at a file before and after and changes in that file format and how it's been distributed amongst the file itself. And it could be actually in a hard drive, it could actually be in a partition. So you use a lot in analysis of partitions. Histogram analysis can be used to possibly identify a file within the hidden message. We could use it to determine a snapshot of a histogram before and after of that file. But again, you'd have to have the before to determine the after. By comparing histograms, you can see a histogram is a very noticeable repetitive trend. Over and over, maybe on multiple files to do it. Then compare the properties of a file. We'll say a property of a file on this one here was on 4/4/2003, 525. It was 240 by 759 XY coordinates. It was the dimensions of the file. The next minute, it was changed to 235 750 properties. You could also do a checksum to determine. Anytime you do use any file that's been changed, it will create a checksum of that file, like a Word document, a bitmap document, things like that. Hex viewer, you can view the hex itself, the binary hex of the bitmap to determine, or the JPEG or the GIF to determine if signatures have been added, e-signatures have been changed. You can see a before and after signature. The only way this could work, though, is if you had the before and after. You'd have to have the before and after to determine it. So, to analyzing contents of a file, if you have a copy of the original, which you may or may not, depending on, you'd almost have to do like a mirrored backup to actually do this. Like yesterday's backup would have to be somewhere in a temporary area. Today's actual live, and then compare the two. But how many networks do that? I mean, how many companies do that? Hardly any at all do that. The only time network administrators go to a backup file is if Joe lost a file today and deleted it. They want to go back to yesterday's file to retrieve it. That's how backups are used mainly. Okay, not for what we're talking about here. Not to say you couldn't use it that way, but it's normally not done that way. There's also many tools that can be used to view and compare contents of a hidden file. Everything from Notepad, hex editors. We'll be using a hex editor at the end of the semester, by the way, when we do the scanning of a hard drive to determine any hidden data on that hard drive or any data that's ever been written on that hard drive, whether it be words, images, doesn't matter. We'll use the software at the end of the semester, an old DOS software actually. It's only like 2.5 megs that can scan your entire hard drive and index it, and then you can search for a word. It'll find that word or words in that hard drive. Because anytime you delete something from your hard drive, even though you trash it, it's still in your hard drive. Doesn't matter what it is. A picture, a document, an image, the residuals of that is still in your hard drive. History cache on Internet Explorer, Firefox, Chrome, all in your hard drive. Never is deleted.
It actually deletes the first character of the file name, and it will get overwritten eventually if you keep on adding
Yeah,
stuff.
keep going. Keep going. But still, you're going to find residuals somewhere for that file, and that's a kind of eye opener to students, but also the same thing to educate people at work. Hey, did you know when you deleted your file from your hard drive, it's really not deleted? Yeah, it is. I deleted it. No, it's not. Let me run the software and show you. And run a software like we're going to show you at the end of the semester, and within 5 minutes you retrieve that file. Oh, well, how do I get rid of it? Reformat your hard drive about 30 times in zero format, every bit on your hard drive with a zero. Oh, I don't want to do that. And so, you think about it, after the lab we do on that, I always have students go, I'll be careful what I search on the web now. But, I've worked in many locations to where we had to do an index of every hard drive every semester of special administrators and determine what they've been doing, and then create a log and report to give their superiors. I see many individuals box up their stuff and have to leave and maybe been there 20, 30 years because they search for something. An example would be this, and this can happen when you're searching the web. You're searching the web and a pop-up comes up of some ad, and we'll say it's for some swimsuit edition or some whatever. You click on it once, done. You don't go back. Those type of things are overlooked generally because that can happen to anybody. But when you are spending 3, 4, or 5 hours on that same website, that's an issue. And so these analyses are definitely beneficial for IT departments. And when you begin to work in IT, or if you have already worked in IT for a while, you will be asked multiple times in your career to do these type of scans on people's machines. And then some companies have you mandatorily do them on machines every so often anyway. Next slide. Helpful analysis programs. This is a great one, winhex.com. It's a really good one. What it does is it allows conversion of ASCII and hexadecimal both. ASCII is real language, real words, real English words that you can read, that people have written to that area, to whether it be a hard drive or it be a file. Then hex is actually going to be a breakdown of zeros and ones in binary. Okay, hexadecimal, 0, 1s, and binary. It also allows you on this program, WinHex, to compare reports. So if you run it every day against a certain folder, it'll give you reports of changes from yesterday to today of every file in that folder. Who changed it, when they changed it. The only thing it doesn't give you is why they changed it. And that's where you have to maybe do some investigation or let people know. Contains file marker capabilities, allows string searching for certain words you want to find, like say words confidential, words payroll, words fired, words bomb, words kill, a whole list of words you can put in there to scan, keyword searches for what people would type in for pornography. You can put that in there. Just hundreds and hundreds and hundreds and hundreds of words you can put in to scan every day to give a report to the boss. This program here I really don't like, but I left it in here. It's the one we use Thursday is much better. Hiderman. In fact, if you want to download this right now, it does have a commercial version, this is a demo version actually. If you download it, and the demo stinks. I don't think they've upgraded it in like 4 years. The commercial version is not too bad, but you have to pay for it. It does the same thing we're going to do on Thursday on the hide and picture. But I actually like the one we're doing on Thursday, the open source one, better than this one. But it's basically same concept, the least significant bit. You hide files and you retrieve files. The one on Thursday is a very small format. In fact, the size of the file is actually about, on your desktop, it's about the size of a, 10 pixels high and 10 pixels wide. It's very small pixels, a very small application. You barely see it on your screen. Here is an example of using Hiderman, and then notice in the viewing the header information of this file, it notices a signature called BM signature on the very first line of this file. That's the signature for Hiderman, by the way, is BM. So there are find this. Whoa, all right. You can find it. Right, this one right here. Steg Spy. Steg Spy will find Hiderman on networks easily. It will not find the one we're using Thursday, hide and picture. But the way to use this one is you actually have to grab the image with Steg Spy, and then it looks at the image, and I don't know if you guys remember VB6. It's an old Visual Basic program. That's the icon for VB6, by the way. The one in the upper left corner says Form 1. Anyway, you have to grab the file, and then it tells you, oh, Hiderman's been detected. But that's it. That's all it tells you. You know what I mean? It doesn't tell you more than that. And do they have false positive on it? Yeah, they do. And so, it's not really the best. And, if the user uses Hiderman, which most likely they won't, the reason I say that is the only good version of Hiderman is a commercial version. Most hackers or people that are trying to steal data or sell data from a corporate espionage type of format will try to find free software. And the one we use Thursday is probably the best out there as far as open source goes. And it's not detected. It's not detected by any type of steg analysis program like this anyway. There are some it will detect though. I'll show you some of them. The other one are Invisible Secrets. That one's pretty good. JP Hide is another one. And I've got one actually here on my Windows machine. I'll write it up on the board. I don't have it in my presentation. I was running it earlier, doing a scan. Stag Detect. Stag Detect is a good one, all one word. It's a DOS-based command prompt. Basically, you put it in like the root of the C drive in a folder called C or in a folder called Stag, and then you do a command CD to the change directory to Stag, run the Steg analysis application. It'll scan your entire C drive for any anomalies for least significant bit. It'll look for excuse me. It'll look for writing header information for known programs that use steganography, and then it'll kick back a report programs it found hidden in the headers. Steganography programs, number one. Number two, it'll also give you a report of files that it thinks might have been tampered with using least significant bit algorithm. And it's a free one too. That one is. Stag Detect is a free one. analysis. Steganography by itself just hides messages. It does not encrypt it. All right. Cryptography, which the hide and picture file we use Thursday, does have cryptography built into the program. You do have to password protect it, and then it encrypts it. It provides a encryption. Cryptography does. Cryptography is a huge field, by the way. If you're into math, if you like math, you're good at math, you like puzzles, you like security, you might want to think about going into cryptanalysis, whether it be for a firm, a large firm. Banking hires cryptanalysis, law enforcement, military, all have high standard cryptanalysis type of jobs that you can definitely get, high paid jobs. I mean, it's high standard, but high paid. I had a military gentleman here 2 semesters ago from, he was in the Marines. Yeah, he's in the Marines. And he was in a cryptanalysis program for 8 years as a Marine. And he did his presentation on cryptanalysis, way over my head. And showed some of the cool stuff that was going on, that what he could tell us anyway, what was going on. There's some of the stuff he couldn't tell us, but some of the stuff he did tell us, which was public domain type stuff that people, he could share. But those of you who've been in the military, you know this probably, but military is used a lot for R&D, for cryptonology, cryptanalysis, web or Wi-Fi security, all these technologies that we're waiting for are a lot of times in the field tested and created in military bases around the world. And so it is a field that he definitely interested a couple of students that semester, I remember, to go at least look into further education in cryptanalysis and the art of cryptography, and how it's used in business, is how it's used in real world scenarios. So how do you reveal the hidden message? Once cryptography has been applied, is cryptanalysis. Cryptography is just hiding, adding security to it would be the cryptanalysis. So knowing the steganography program used to hide the message can be extremely handy when attempting to reveal it. Identifying and cracking the algorithm, unfortunately, some of these programs use very high encryption, like 128-bit encryption. Good luck. Not going to happen probably. Reveal or crack the password, seed it, secret key. Practically all steganography programs use a password to hide the message. The one we use Thursday does. The one I showed you earlier, a few slides back, the demo one, you can't put a password in. I think the demo one is just trial for the username and password. But the one we'll be using Thursday is already in the lab folder. You can already, download it. It does have a PDF file in there to show you how we're going to do it. But cryptanalysis is basically identifying the program used to hide the message. Number 2, identifying the location of the program, signature in the file. 3, identifying the location of the password in the file. 4, identifying the location of the hidden message. And then 5, identifying the algorithm used to encrypt that hidden message. This is a pretty good website, actually. I'll recommend. Outguess.org is one of the websites, actually, I believe, where was created, Steg Detect was created there, that gentleman. Outguess.org started a JSTEG, which basically is a password guessing dictionary attack type of software that basically premises to find Steg bitmaps or files on your drive and then crack that password to be able to open up that file with whatever program it was created with. Outguess.org, it's a kind of a messy site, but he's got a lot of cool stuff on it, a lot of cool investigation reports, things of that nature, some presentations out there. That software, Steg Detect, is on there. He created for both Windows, Linux, I believe. And then also another one I recommend is a Knoppix Penguin distribution called Sleuth Forensic CD. 2 weeks from now, I'll be passing out a DVD called Backtrack that has tons of network utilities for network security folks. But also I'll be passing out one called std that was actually originally used by Cisco a few years back when we started our network security analysis assurance program. And I was involved in creating about 15 or 20 of the labs for that and keeping them up. But std was definitely big back then, not so much anymore, but it's still cool. It's a cool tool. It still works. It's based on Knoppix as well. Knoppix was a Linux distro created by a German network administrator that wanted a tool to be able to go into any computer and be able to fix registry, fix BIOS, run maybe antivirus scan, things of that nature. It's grown from that premise to Knoppix now is in like 100 different flavors, from just casual users of Linux to media distros to security distros. And what's cool about it is it's all free, and you can download all these different versions of Knoppix from knoppix.org. I recommend that website as well, knoppix.org. You can download any ISO you want, burn it to a DVD, and run it live on your computer and play with it. And the STD version of Knoppix is the one focused for you guys, network security folks, wanting to learn about network security. It's got tons of tools in there for penetration testing, password guessing, steganography, steg analysis, crypt analysis, are all on those softwares, and it's totally free to use. Definitely recommend it. I will be in 2 weeks. I'll giving you a DVD and going over Backtrack, which is probably the most popular today in network administrating fields for network security. And it's got like 1,400 applications on the actual distro, the live distro. And of those 1,400, 800 of them are devoted to network security professionals for penetration testing. But also on the flip side, it's also used by hackers as well, just so you know, used by hackers to do the dirty deeds that they want to do on a network. But it also can be used by network administrators to do penetration testing on network to determine if their network's healthy or open for anything. You might have heard of this term, brute force. Brute force basically is also called reverse engineering. Could also be, on the flip side, reverse engineering, which is taking a software, reverse engineering it to where I know how it works, I know the code behind it, and I can basically recompile it to run it on on my machine, basically, to maybe decrypt or open up a program or open up a hide and picture type of file.
Alan Turing in World War II, they captured the German Enigma, and he reversed the engineering.
Yes, that's right. Reverse engineer. Yeah, you're right.
Actually, our machines took code were almost God, so we sank ships that were allies of us, killing soldiers, so that the Germans wouldn't get our codes.
Right. Yeah, the reverse engineering, you might have heard of that term. It's been used in all different fields. The way it's used now currently today is, an example would be this. Any new software that any company creates, a popular company, let's talk about one like, say, Adobe. That's a popular one, right? What's a popular program within Adobe Suites? What's a popular one that people have used or people do use? Acrobat, okay. Acrobat. We'll talk about Acrobat Pro, right? You have to pay big bucks for that one, right? It's expensive. Well, there are programs that actual programmers actually that have reverse engineered Acrobat Pro and put it online to where people can download it and now run the Acrobat Pro at no cost by bypassing the key, embedding the key, whatever, hacking the key to where it doesn't need one at all. And another program that hackers create and use is called keygens. And keygens actually can be downloaded by anyone to generate keys for these softwares like Acrobat Pro or Microsoft Office. But the most stealth mode probably would be the reverse engineering of these applications, literally weeks, if not months, after they've been released. And that is kind of fishy almost, because when operating systems are released, they're pretty intrinsic. These operating systems are, or the applications are, It's almost like somebody's on the inside sometimes letting out this information. I'm just guessing. I don't know that. Because within days, or let's just talk about any phone from Droids to iOS. Within days, somebody has a hack to do whatever. Within days, and maybe while it's still even in beta, possibly. And are there disgruntled programmers out there? Yeah. Are that maybe turn black hat hackers, not white hat hackers, but black hat hackers? Definitely. And can they do damage? Yeah, definitely. The government, by the way, right now, they have been for a while, is scouring college campuses for very smart programmers or up-and-coming programmers to grab a hold of, pay them big bucks and give them a cubicle with all the Mountain Dew they can drink and the pizza they can eat, and ship them to Washington. And actually, I had a high school student of mine worked for Washington for a few years as a programmer, and very sharp kid. Got kicked out of school a few times for some of his he was so sharp. But they grabbed a hold of him, and programmers, though different breed, usually a little bit of anarchy in every programmer, a little bit of anarchist inside of a programmer, against the man, against the grain, against the flow. We got to do it your way. I'm one of those people, for sure. But I'm timid, a little bit as I get older. But when I was younger, much more. But with brute force engineering, reverse engineering, when you have unlimited time to work on something, it's amazing what you can get done. Right? I agree. When you have unlimited time, and so a lot of times, high school students, even college students that live in a dorm or don't have to work a job and maybe working part-time, have a little bit more time maybe than maybe the friend of theirs next to them in class has a wife and 3 kids and a job, and they can basically spend a lot of time to do things and to get in trouble sometimes, but also learn things too that can help all around. And so with brute force, basically, it's just taking a password that you need to crack and hitting at it every known algorithm you can think of, from dictionary cracks, dictionary words, to different algorithms of passwords, to what's called rainbow tree of passwords. What a rainbow tree is basically is millions and millions and millions of combinations of passwords that have been created or used over the years in a file, and using those passwords to hit a program to crack it. Because believe it or not, there's only so many passwords that people use mainly in life. And a lot of them are repetitive. What I mean by that is dog names, kids' names are popular passwords. Common surnames, common last names are popular passwords. When hackers first started hacking networks, the common password for a lot of admins back then in the late 80s was God, was the password. Okay? That's what they use for password. Caps God as the password. Like, really in your face. But passwords contain, and contents mask can use an algorithm, and algorithms are based on some type of secret key. Algorithms then base that on a password, and algorithms based on a random seed key are found somewhere else in the file. Like there's a lab we do this semester where you guys learn how using a piece of software to hide a partition, and within that partition hiding process, you can create a seed key that you have to have the seed key to even open up the program to run. Without the seed key, it won't work. And that seed key can be installed on a USB drive, right? So it has to be plugged into a USB drive. The application looks for that file. If it doesn't see that file on the USB drive, it won't run. And so seed keys are used a lot of times on passwords as well. Algorithm testing and also creation. Some of the algorithms used, you might have heard of these in your mathematical history of math. XOR, divisional leftover, DES, 3DES, IDEA, and AES. These are all types of encrypted algorithms for the types of encryption could be used in these segments. Don't worry. This is the last 2 slides we'll go over. Case study. Okay, we're going to determine here the password used with camouflage. Camouflage is a steganography program used to hide a file in a picture here. The location of the password was determined by a multiple hex program that allows you to search for hex strings. Was found in this location, this hex location on the file, 76F009F6. The password is known to be test, which is that in hex. There are conversions, you can convert hex to ASCII and ASCII to hex. Well, that converted to the word test. This tool basically takes a hex file and then can determine the bit within a byte, and then can actually determine if there's any XORs within the algorithm in that file, and then it can basically give you, in this one, just a basic calculator. You can have a byte calculator, you can have a binary calculator, a hex calculator, and then basically it'll also give you numbers here to determine the strength of that byte as far as was there any they call low nibble, high nibble, bit select nibble, meaning least significant bits were modified. The lower the number on the left side means this probably wasn't attacked or used. The right one, anything over 100 generally means it has been some type of algorithm applied to this. So on Thursday,